Okay, let's give you guys some practice. So this area here is equal to pi. So if the area here is equal to pi, what must this angle be? So work out beta. What must this angle be? So the red line here is given by this. So the area is pi. The area here is pi. What must this angle be? So work out beta, and this is here to help you. Okay, so press pause and have a go. Okay, so to do this, remember the formula for the area is given by this. We want to integrate it from 0. We want to integrate it when theta is 0, from 0 all the way to whatever. This is what we're trying to work out, beta. So we are integrating from 0 to beta, and we know the area is pi because you were told that this area here is pi. So if this is pi, then we can set the area to be pi, and then r, we can put this. We're going to square this and then put it into here. So from here, that will then take us to here. Now, when you square this, at the moment you've got one block multiplying with another block. So when you square it, you're really getting it and then multiplying it by itself. So you've got one block here, and then you're multiplying with this squared this thing, and then you're multiplying with the exact same thing, this thing here, and then the exact same block here, e theta squared over pi, and then this times this will give you theta to the, well, you would then add the two indices. That would then be 1. That would then give you this. So multiplying this with this will then give you theta to the power of 1 if you want. And then this thing here, you simply get this this index added to this index. So that will then give you this. Well, square this thing here, it will then give you this. Remember, we're integrating from 0 to b, and we're trying to to beta. We're trying to work out beta here. This is what we're trying to work out. So now it's just a matter of integrating this. So now we need to integrate this. That will then give us this. So hang on, to integrate this, at the moment you've got one block multiplying with another block. We are trying to integrate this. When you're integrating, try to keep an eye out for something being the exact derivative of another thing. So if you look at this here, this is the exact derivative, well, near enough the exact derivative, if that makes sense, of this thing here. Because here you've got theta squared, and then here you've got theta. Well, when you differentiate theta squared, when you differentiate it, it gives you a constant and theta to the power of 1. So this theta here is near enough the exact derivative of this. So when you're integrating, keep an eye out on something being near enough the derivative of what you're near enough the derivative of this. So what I'm trying to say is, when you're trying to integrate this, you are looking for something in such a way that when you differentiate it, it will give you this whole thing here. So make this to be your initial guess. Make this to be, so imagine this as being in a bubble here. So make this to be your initial guess. 2 theta squared over pi. Now when you differentiate this, so this is your initial guess. When you differentiate it, it will give you this. So imagine this as being a bubble. So it will give you e to the power of the bubble intact. So that's 2 theta squared over pi. And then you've got to times with the derivative of the bubble itself. So that will be 4 over pi theta. So yeah, so when you differentiate this, it will give you this, but then you've got to times with the derivative of the bubble itself, which will be this. So when you differentiate it, it will give you this. So this is your initial guess. When you differentiate it, it will give you this, 4 pi theta, and then you've got your e theta squared over pi. You see, this thing here is very similar to this. All you need to do now is negate this this 4 over pi. So to make the adjustment to your initial guess, make this adjustment pi over 4. Now when you differentiate this now, pi over 4, this thing here, then it will then give you this thing here. The point I'm trying to make is rather than using new substitution, you try and spot try and spot something being the exact derivative of another thing. So because if you look at this here, this is squared, and when you differentiate the squared, it will give you theta, and this thing here is this. So you don't always need to do the u substitution. You can just jump to it. Well, anyway, integrate this. It will then give you this. So now we can put this into here. Okay, so we can put it into here. That will then give us this. So this is beta here, and then put this into here. This whole thing here will be 0, making this whole thing here to be 1, making this whole thing pi over 4, making this thing here pi over 4. The point is that if you put this into here, this thing will become this. Put this into here, then it will become this, and then blah blah blah. Really, just same denominator, merge these two together, factor out the pi. That will then give you this, and then remember, originally we were told that the area was pi. So originally the area was pi. So the original area was pi. So now we can just divide both sides by pi. So from here, divide both sides by pi. That will then give you this, times 8 to both sides, and then plus 1 to both sides. That will then give you this. So now take the natural log of both sides. That will then give you. So from here, take the natural log of both sides. That will then give you this. Imagine the 9 as being this, 3 squared. So you can take this out here. That will then give you this. And then let me think. So that will then take us to here. And then now times both sides by pi. That will then give you this, and then divide both sides by 2. That will then give you this thing here. Now square root it. So beta must be this. So this is your final answer. Okay.